In this video, I'm going to demonstrate how to prepare a passenger manifest using the Westwind weight and balance form. First of all, notice that the weight and balance form is nothing more than an Excel spreadsheet. And as with all spreadsheets, there are tabs at the bottom, just like with the daily schedule. And each tab at the bottom is a different aircraft. Starting over on the left, the first 6 tabs are the Caravans, and they are highlighted in orange. The next 4 tabs are the 207s, followed by the 206. When preparing a passenger manifest, make sure that you select the correct aircraft very first thing. Common mistake. And there's nothing worse than preparing a manifest in the wrong aircraft. So I'm going to do this demonstration in 9317 Mike. So I'm going to go down here to the bottom and click on 9317 Mike. Then make sure that up here it says 9317 Mike as a way of verifying that you are in the correct aircraft. The next thing to notice is that this is a protected sheet. If I put the cursor anywhere other than in one of these highlighted cells, it won't allow me to do anything because it is protected. All of the cells on this particular page of the spreadsheet are protected except for the highlighted cells. Now, to navigate around in the highlighted cells, there are 2 ways to do that. You can use the cursor and go from whatever cell you want to any other cell. The other way to do it is to use the tab function. Once you're in a cell and you hit tab, it will take you to the next highlighted cell. Now, when preparing a manifest initially, I suggest that you use the tab function to go from cell to cell in a nice, neat, orderly fashion. If you are making changes to an already prepared manifest, then it would be more expedient to simply use the cursor and highlight the cell that you want to work on. All right, so let's get started. Starting with the date, today is the 26th of September. So I will type in the date and hit tab. For this particular manifest, we are doing it for a PGX tour. So type in PGX for the code. And the flight number, which would come off the daily schedule, is D045. Hitting tab, we go down to the departure. Well, this is a Deer Valley flight, so I will type in DVT, hit tab, and we want to enter the time of departure. Now, this is not the actual time of departure. That is for flight following. This is simply an estimated time of departure. These actual departure and arrival times do not need to be accurate as far as real time goes. The only purpose of putting the time on the passenger manifest is for the calculations within the weight and balance form. Okay. So scheduled departure time is 8 o'clock. Now, it's also important that you do not use hour and minutes. We use decimal times. So at 8 o'clock, it would be 8.0. Do not use the colon. If you use 8:00, it will not work. We must use time in terms of decimals. So the departure time is 8 o'clock, 8.0. Clicking on the tab, the arrival will be at GCN. And the arrival time is going to be 9.6. So that's actually for this particular aircraft. I'm going to go back and come back. Let's put 9.75. Now that would be equivalent to approximately 1 hour and 45 minutes. Now, when doing these calculations, you'll notice that Excel is rounding some of these values. It rounds it up to 1.8. That's just to give us a little bit of a margin of error. It's going to overcalculate the amount of fuel that we need, which is better than underestimating the amount of fuel. Now, it will automatically put for the next departure the same as the arrival. In these passenger manifests, we can do 2 departures on one sheet. Any more than 2 departures, then we need to do another sheet. But on any given sheet, we can do a departure and arrival, a departure and arrival. So the second departure right here is going to be the same as the arrival. So it automatically puts it in there. The time estimated is going to be 2 o'clock in the afternoon. So we need to put that in 24-hour time, military time, because if I was to put 2 o'clock in the afternoon as 2.0, you can see that that is going to be before our original departure time. And so it's giving me a negative time down here. So I have to go back. I'm going to use the mouse now, go back to that cell and put in 14.0. Okay. Now, the arrival time, the arrival airport is DVT, and the arrival time is going to be 15.0. Okay, so now over here, it tells me that I have a 1-hour flight. Notice that the leg 1, the flight time is 1.8 hours, and leg 2, the flight time is 1 hour. Again, the most important thing to remember here when entering times is use decimals and the 24-hour clock. The tour guide and the language is not that important for now. That is something that we would need to put in if this was a tour that we were doing in Page with foreign visitors. So let's go down to name. So I'm going to be the pilot, and I am going to type in my name. And I'm going to tab to my weight, which is 180 pounds. Now the kilograms, if you have passengers who give you their weights in kilograms, as many Europeans do, it will automatically convert it into pounds. So in the next, let's say that my co-pilot is going to be Eddie Anderson. And if I was to put his weight in kilograms, it's going to automatically convert it into pounds. So you can see 23 kilograms is going to be converted into pounds here plus 10. And I didn't mention that up here. When I put my weight in pounds, notice that the weight here says 190. In this column, it's automatically going to add 10 pounds to each person's weight. Again, that gives us a bit of a margin of safety. We're going to be overestimating all of our weights. This is in accordance with our operations specifications. Well, Eddie doesn't want to give me his weight in kilograms. That was just for demonstration purposes. Let's say that he weighs 120 pounds. And then this is going to be the Anderson family that I'm taking. So there's going to be Maria Anderson. And Maria weighs 150. And then we have Ken Blackstone. And Ken weighs 200 pounds. And then we have, let's just say that we have Sean Blackstone. And Sean weighs 195 pounds. And one more passenger, let's say that this is Susan Albertson. And Susan weighs 105 pounds. So we have a full flight in the 207s. So notice that we can have the pilot plus 5 passengers. Now, going down to the baggage, we automatically put in 15 pounds in the forward baggage compartment, which is up front in the nose of the aircraft. Generally speaking, the aft baggage isn't going to have anything in it, so we can leave that blank. If you do put some items in the aft baggage in area D or in the aft baggage, then you would have to add some weight in there. Let's just say we add 10 pounds to aft D baggage. Now, the ramp fuel, maximum fuel for the 207s is 438 pounds. If I put 438 pounds here, then notice that over here, when we look in the envelope, this is what is referred to as an envelope. This is the weight and CG center of gravity envelope. Without going into a lot of the background and the theory of weight and balance calculations, you can ask your favorite pilot for that information. The important thing for the office staff is that these little red dots and the lines connecting them are all safely within the boundary of this CG envelope. And I'll give you an example of what happens when it goes outside of the CG envelope. But with the calculations that we have done right now, we are safely within the envelope. Now, this first little red dot up here, if I highlight it, notice that it says 3746.3 and 46.65. Now, that will be associated with the 437, yep, that will be associated with the takeoff weight over here. Our takeoff weight is 3,746 pounds. The center of gravity is 47, and this is what we call the moment. Now, for doing these calculations, you don't need to worry about the CG or the moment. All we need to do in the office is to enter the data and make sure that these red dots are within the boundary. The second dot down here, notice it says 3557. If you look at the number 3557, and 46.58, that corresponds to the landing weight down here. So we see where it says landing weight 3557. That is this dot right here. So when we take off, we are at 3746, which is right here. And then when we land, we're losing weight. Notice that this is dropping down as it should. And so when we land, we have a weight of 3557. Now, that will also be our takeoff weight for leg 2, minus a little bit of that for taxiing, which is built into the program. And then the final dot down here would be our second landing weight, which is 3443. And we can see that down here. Now, notice, as I just said, that the takeoff weight, 3551, is a little bit less than the landing weight. Even though we're taking off and landing from the same airport, we do use a little bit of fuel in the process of taxiing. So that's why these numbers are slightly different. They don't show up as two separate dots on here. They'll just show up as one dot because the difference is very insignificant. So it's important to be able to read this graph and understand what you're looking at. Once again, the top dot is the takeoff weight, the first takeoff weight. The second little dot down here is the first landing and the second departure weight. And then the third dot is the final landing weight. All of them must be within the envelope. So this looks really good. You would look at this, everything is good. You would then print this out so that the pilot will have it. The pilot, according to company policy, must read this, verify it, okay it, and sign it, and carry it with him in the aircraft. Now let's just suppose that we had an issue where Susan Albertson weighed 300 pounds. So I'm changing the weight up here to 300 pounds. Now notice what happens. The initial takeoff weight is way above this top line, which means we are overweight. You're also going to get a warning up here. Notes and warnings, overweight, maximum gross weight is exceeded. So we say, uh-oh, that's not going to work. So we're going to change her back down to, let's say, 105 again. And now we look good. You also have to make sure that you're not, that the, let's say we have too much weight too far forward. Let's say the pilot weighs 300 pounds. And let's say that there's nobody in the back. So let's take her out, and there's nobody in the next seat. And let's say that Eddie Anderson weighs 300 pounds as well. Now notice that we have exceeded the forward center of gravity. If you're going forward of this line right here, you are exceeding the forward center of gravity. So that is also a no-no. So again, you have to make sure, say, uh-oh, well, these people are too heavy. Maybe I should move Eddie Anderson to the back. So let me move Eddie Anderson to the back at 300 pounds and delete him here and say, okay, we're good now. So one of the things that you have to do with your passengers is sometimes move them around so that you are within the forward center of gravity envelope as well as maximum weight. If you go over the maximum weight up here, you simply can't do the flight with that amount of fuel. So let me add, let's add Jill Coughlin as another passenger. And let's say that she weighs 100 pounds. And now we're a little bit overweight. So we're going to say, okay, well, Eddie, and so what can I do if I'm overweight? I can't move my passengers. I mean, I can't take a passenger off the airplane. So the other thing I can do is change my fuel weight. I'm taking full fuel. 438 pounds down here is full fuel for the 207. Well, I don't have to take full fuel. Let's say I can do this with 350 pounds of fuel. Okay, so now notice that when I put 350 pounds, that the lines move down and I am now within the envelope. So you can just play with these numbers to determine what the optimal, what the maximum amount is. I can say, well, could I take 370? So put 370 in here. Yep, I could take 370. What about 400 pounds? I could put 400 pounds in there. And so by doing it by trial and error, you can see how much you get by doing this. Another thing I want you to take a look at is this number over here. So at 400 pounds, this number over here, 64, is approximately the number of gallons of fuel that you would need in the airplane, which is 64 gallons. And that's based on 1 gallon of fuel being 6 pounds. So 400 pounds, we can take 64 gallons of fuel. When we land, our landing weight is 3609. We're going to have 196 pounds of fuel, and that's going to be 33 gallons. Then we're going to deduct a little bit of taxi fuel to get a takeoff weight of 3603. Our takeoff fuel is 190. The difference between the landing fuel and the takeoff fuel was our taxi fuel. And so that's the difference in our takeoff and landing weight, is because of taxi fuel. Now, when we land, we're landing with 82 pounds of fuel, which is 14 gallons over here, at a weight of 3495. All right, so I'm a little too close to maximum weight up here. So I'm going to bring the weight down to 380, or the fuel down to 380, to put me just a little bit under that maximum gross weight line. Okay, so it's important to make sure that you can read and understand these particular numbers, but in particular, the numbers that are highlighted in yellow. All right, there's lots of things that you can do to play around with these things. And as you gain more experience, simply ask questions, and someone in the office will be more than happy to answer your questions. And if necessary, I can always make another short little video to answer some of your questions. All right, hope you enjoyed the video.